Hello. Um, let's see. Okay, do you see the desktop? Can you hear me? Everything seem okay?
Yep.
Yes.
Great, thank you. I have to pull up some windows, get the chat up. Okay. Okay, yeah, people coming in now. Almost everybody's here now. Okay. I hope you had a nice weekend. And we have a short week now. Now we have a short week. And uh, today we're going to talk about these two sections here. We're going to start, well, we're going to talk about these two sections here. We'll talk about section 4.3 and we'll start 4.4. There's a lot to say about nested loops. It's a pretty big topic. So we'll start on it today and also spend next week talking about it. Okay. And you're going to have another programming assignment up there. I haven't had a chance to work on it. So right now, there isn't the fourth one up there, but it'll be up there pretty soon. Okay. And so for now, um, keep, I have, if you try these coding bat problems, those are what you should be working on right now. The coding bat problems are very, very good problems. If you have questions about them, please ask me if you have trouble doing any of them or if you have questions about how they should be done. Okay, because the coding bat problems are really, really good things to be working on. That they're about as good an indication of what you're trying to what it is you're trying to learn in this class is literally to be able to solve problems like these. Okay, that they really are about as good a measure of what this class is trying to teach. Okay, and let's see. Let's go ahead and and there's a reading assignment for the last bit of stuff about loops, and then we're going to review. We've talked about methods before, and we're going to go back and do another review of methods. So we're going to, chapter 5 in this book is another chapter on methods. And we've kind of skipped methods. We haven't been talking much about them for a while. We've been talking about if statements and now for loops. And we've kind of left methods behind. And now we want to start mixing them all together. So there's a whole nother chapter on methods where we'll go back and redo methods, but using for loops and if statements, and so we can write much more interesting methods. And we'll talk more about return values and all the and parameters and all the important ideas of methods. So we're going to start this chapter on methods. And you can see it's not a long chapter because it's kind of, from our point of view right now, it's a little bit of review. We've talked about all these things a little bit, and we're going to talk about them again. But like I say, this time we're going to be making use of for statements and if statements and things like that. Okay, so that's the reading assignment for over the weekend, is two short sections that end the chapter on loops. These are actually, well, this one's actually literally is just a summary section. Okay, so this one just summarizes, it's only about a page long. It only summarizes loops. And this one is also really short. Two short sections ending the chapter on loops, and then a beginning of a chapter on methods. Okay, so that's the reading assignment. Okay, and also here are some practice problems on loops that are from this book. Okay, so here's loop problems involving mixed up code problems. Okay, and these are very good to do. These are kind of warm-ups for doing coding bat problems. These are easier than coding bat problems, but these are a prerequisite to be able to do coding bat. So make sure you can solve these pretty carefully. Make sure you feel comfortable with these. And if you have questions about these, please ask. But they're a good way as a warm-up to doing the code. Because here you see some of the code, you just have to put it in the right order. In coding bat, you have to come up with everything yourself. So that makes it quite a bit harder. Okay, so do these practice problems. Okay, and with programming, it's like learning a foreign language. If you're not constantly practicing it, it's not going to sink in. So that's why I'm pointing out lots of things for you to do. Coding bat problems, these problems. The doing it is way more important than reading about it. In fact, the better way to read is to read while you're doing these. Keep trying to do the problems and then reread as things come up that maybe you don't understand in the problems, but do the problems is the more important thing. Okay, now let's want to do code about loops and strings. So I have some example programs. I forgot to put them on the desktop. Okay, now I got them. So here's some example programs I want to look at. Okay. Okay, so the basic idea of combining strings with loops is that you want to do what we call walk through a string. You want to traverse, people use the words traverse a string or walk through the string to see all the letters in the string. Now, let me comment out the part we're not using. We want to look at these examples. Let's just look at the first one. So we'll just, okay, so I create a string. Okay, that's just an example string. And then I'm going to do a for loop where I'm going to walk through the string. So I'm going to take, remember, a string is nothing but a bunch of letters with an index. So the capital H is index 0, the first E is index 1, the second E is index 2, the first L is index 2, the second L is index 3. Okay, so I can create a for loop that takes I for index. We usually use the letter I a lot for index. Start at index 0, that's this H. Let I go up to string.length. Now, this string here has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 characters in it. So its length is 18. The period is character 17. So if I wanted to remind you, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I can't count anymore. Well, you can say this is 10, 11, 12, 11, 12, 13, 14, 15, 16, 17. There's 18. So 18 is at the end, after the string. So notice, but I don't go up to index 18. This is a strictly less than. So the I starts at 0, and the I goes to 1 less than the length. So it's actually going up to 17, which is the period, so that's taking me across the whole string from one character to the next. Now you could write this, and nobody writes it this way, less than or equal to string length minus 1, because the string length is 18. 18 minus 1 is 17. That's the last character. You're going up to and including the last character. But nobody writes it that way because it says the same thing, but you type more characters this way. Less than or equal to string length minus 1. Everybody gets used to writing it this way, and you just remember that that goes from the beginning of the string up to the end of the string, up to the last character of the string. But you have to remember to write it this way. I equals 0, I strictly less than the length. And that'll go from the first to 1 less than the length, which is the last character. Okay. Now, what am I going to do here? I'm going to just print out each letter one at a time, because what I can do anything I want when I walk this string, and we'll see. We can all these different loops do different things as they walk the string. And a lot of times, this is how you solve problems. Okay, this is how you could, for example, find uppercase letters, find lowercase letters. We'll see, you can replace letters in the string as you go along. So what here I'm going to do is just print out the string. I'm going to print each character one at a time. If I take the substring from where I am to one past that, remember, substring doesn't include, it goes from this index up to, but not including that index. So if I go from 0 to 1, I'm printing out just 0. If I go from 1 to 2, I'm printing out character 1. Okay, so this is going to print on a line each character. Okay, so let's just watch it. Okay, so there's the, notice I'm using the wrong memory diagram here. Remember, strings are actually over here in objects, but I didn't check that little box. So right now it doesn't matter so much, but I didn't check that little box to put the strings over here under objects where they really belong. So I'm using their default way of showing strings. Okay, then I start my for loop. My for loop creates a letter I, a variable I. Okay, so right now I created the I. Okay, now I click forward, and actually remember we talked about how a for loop works. It's real important to realize that this I came from doing just that part of the for loop. When I click forward, I'm going to jump from that part of the for loop to this part of the for loop. I have to check if the condition's true. So notice I'm going to go from step 4 to step 5, and I stay on line 7. Okay. Well, it checked. I did this thing here, and it checked that it was true. So I'm now about to do line 9. So if I go back, okay, I created this. Now I'm here. I'm about to do this thing. So step 3 is creating I. So do step 3. Step 3 created I. Step 4, notice I didn't move from this line. Step 4 is check if I is less than the length. 0 is less than 17 or 18. So step 5 puts me inside here. Okay. Now I print out. I'll see a printout of one letter. Okay. Now I'm back up here. What's real important is I'm back to this line, but where am I in this line? Anybody, where am I right now? What is it I'm about to do in line 7? So what's step 6 do? How does a for loop work? There's 3 parts to the for loop. Remember, we call this initialization, test, and increment. What's step 6 about to do?
Step 6 is about to check if I is still less than the length of S1.
Okay.
Which
now,
should initialize it as 1 now.
No. That's not what step 6 does.
Okay.
Okay. So go back. Let's start from So step 3 was creating I, and you can see it appear over in the right-hand side. So step 3 is create I, but I'm still on line 7. Step 4 is check if I is less than the length. Okay, so step 4 is going to check if I is less than the length. It is, so I'm about to do line 9. Step 5 is do the print line. So now I do the print. That was step 5. What's step 6? Now I'm back to line 6.
Check if I is less than the length again?
No.
Oh, someone just said it on the chat to increment.
Yeah, you go back to the increment. Now, go back to, remember last week, I drew a picture. See, now we're watching this picture. You come in and do the initialize. That was, in our case over here, where's the right window? Oh. Okay. Over here is the idea of a for loop. Over here, we're actually tracing through one. So if we go back a few steps, okay, we're at step 3 on line 7. Well, line 7 is this whole line, but step 3 is the initialize. We come in and do that first. Then go forward, step 4. We're still on line 7 because we went from initialize to test. Then forward one more, step 5. Now we go inside. So we do step 4. Now we're ready to do to go inside. Okay. So step 4 was doing the test. Now we're inside. Okay. Now step 5 is do the print. That was do this. Now forward one more step, and now notice we're going to go back up to this line up here, but we're in the increment part. So now step 7, okay, we're up here, okay? Okay, so actually, step 5 was line 9. Step 6 is the increment, okay? Okay, now after you do the increment, you still stay on line 7. You stay on line 7 and go to the next step. Notice when I click forward, I'm going to go from step 6 to step 7. I'm staying on line 7 because I'm going from the increment to the expression. Okay, so I went from here to here. Okay, okay. Now notice also I can go back. See, I changed from 0 to 1. Okay, that was doing this part of line 7. Now I'm testing it. Is 1 less than the length? The answer is going to be yes, so I'm back down in here. Okay, now watch as I click forward. How many steps does it take? How many steps does it take to go from here? How many steps does it take to go from this line back to this line? I'm at line 9. I'm going to go from line 9 to increment to test back to line 9. So that's going to be 1, 2, 3 steps to get back here. 1, 2, 3 steps to get back there. 1, 2, 3 steps to get back here. The 3 steps are go up here, go over here, then come back down here. So the 3 steps from here are go up to here, over to here, back down to here. Follow 3 arrows. 1, 2, 3 arrows. Okay, right? So we're seeing that. Now we can actually, there's a little trick we can do to make this even clearer that we're stepping through the pieces of this loop. Let me go back to the code and do a funny thing with this loop. I'm going to kind of fool the Java visualizer by putting each piece of this loop on its own line. Okay, Java doesn't really care about how you indent or anything like that, but now notice this is on one line, this is on another line, and this is on another line. Now watch what happens when I visualize it. It ends up visualizing better now. Okay, it looks kind of ugly, but watch what happens. Okay, so I start with creating string 1. Okay, I enter the for loop there. Okay, so I jump in to initialize. The next step is to test. The test is true, so I jump now down to line 11. Okay, print. Okay, now I go back up to here. See, after I do the print, I go over to here, but see, it's on a line by itself now, so I see it as its own line. I do the increment, so I goes to 1. Now I'm going to go up to here. Okay, now I check the length. That's true, so I'm back down here. Now you see the 3 steps. Step 1, step 2, step 3. I'm back to here. Okay. They introduced an extra step down here. The visualizer got mixed up. It introduced an extra step that doesn't do anything. That's kind of weird. They actually did get goofed up by me breaking up this into 3 separate lines. They show you going from here to here, down to here, here to here, down to here, but they showed this line here as 2 steps. See, I'm at line 11. I'm going to go forward. I go to line 9, but then I go forward again. I stay on line 9. Okay, that's a little bit of a they kind of miscounted steps for some reason. But now what's important is I go from line 9 to line 8, because you go from the increment to the expression, the test expression. Then you go back into the loop. Okay, then into the increment, then to the test, then into the loop, then into the increment, into the test, into the loop. And so now we're cycling, we're looping in this loop here. And as you learn to use for loops, you really have to keep this picture in mind. You cannot read these from left to right. You have to, force yourself to think this one, 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 this one. Yeah, because otherwise you can't write them. Otherwise you won't know what they're meaning. You won't know what you've written if you don't follow it in your head as, start here, then go here, then do this, 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 this. Okay, and this one kind of shows us now how we're looping. Okay, do what's in the for loop body, increment, test, do what's in the for loop body, increment, test, do what's inside, increment, test, do what's inside. Now this is going to increment 18. Yeah, see, I'm up to 13 now. Okay, so I've still got a few more loops to go, 14, 15, 16. And as I'm doing this, this program is printing out the letters. See, it's printing out the letters one letter at a time on the line. So I'm just showing that I'm stepping through the string. I'm not really doing anything with the string. In some of the other examples, we'll do something with the string. We're not really doing anything with the string. We're just stepping through it. And I still have a few more steps to go. Okay, now I is 17. Okay, so I just became 17. 17 is less than 18. The length of that string is 18. Now I've got one more letter to print out. If I look down here, I haven't printed out the period yet. So I'm at the end of the loop. I'm doing the last step of the last time through the loop. Okay, so go down here. Now I'm going to print the period. Okay, there was the period printed. Now I'm going to change I from 17 to 18. 18 is the length of the string, but 18 is not strictly less than 18. So now this one, I go over here, I do the test. Now the test finally fails. 18 is not less than 18, so I'm done. Okay. Okay, so that's the pattern of what we call walking a string, stepping your way through a string to do something. In our case, we're not doing much. We're just printing each letter of the string out by itself. Okay. Now, you don't have to use substring if you don't want to do that. Notice that the way I printed one letter was I used a little bit of a trick. The substring from I to I plus 1 is the ith letter. But there's also a char at method. Now there is a slight difference. This gives you a character, which is not the same thing as a string. This gives you a string of one letter. This gives you one letter. Slightly different, but they're almost the same thing. But this is a string holding one letter. This is one letter. It's not a string. You can't. There's less you can do with this. You can't you can't call two uppercase on this, for example, but you could call two uppercase on this if you wanted to. Okay, right? So, but if you visualize this, whoops. Oh, I typed the comment thing wrong. If you visualize, the two loops do the same thing. This one prints out, this loop prints out every letter, one on each on a line, and this one prints out every letter each on a line. And if you just go to the end and look at the output, you see that one of them printed, see, they just print the same thing, every letter on a line by itself. Okay, sometimes you want the string that is one letter, sometimes you want one letter. Sometimes one is better, sometimes the other is better. Many times it doesn't matter which one you do. But this one will work just as well as this one. We probably use this one more often, slightly, than this one. Okay, all right. So those two do the exact same thing. Okay. Now let's look at let's look at the one in the middle. Let me comment out those. Okay, let's look at this one in the middle here. What does it do? Okay, notice I printed blank. Well, I don't need the blank line anymore because I dropped those. But there's the code that steps you through the line for index from 0 to the end of the string. Step once at a time. Okay. Then this one's just going to print the substring that starts at 0 and goes up to I plus 1. Okay. Well, now let's think about it. I starts at 0. So I plus 1 is 1. So that gives me the string from 0 up to and not including 1. Okay. Or another way to read this is going to print the string starting at the beginning up to but not including the ith letter. The ith, well, up to the ith letter, because it goes up to not including the ith plus one letter. See, the substring goes from this up to and not including this. Since this is I plus one, I'm actually going from 0 up to I. So I'm actually this is a trick to go from 0 up to I. You do substring from 0 up to I plus 1, because substring doesn't include the last letter. Okay, so this will go from 0 to 0, then from 0 to 1, then 0 to 2, then 0 to 3, then 0 to 4. So it's going to print out more and more of the string. Each line is going to print out a little bit more of the string. Okay, so if I go to the end, you can see 1 letter, 2 letters, 3 letters, 4 letters, 5 letters. See, it went from the beginning. It printed out the string in pieces. Okay. All right. So that's just shows you a little thing you can do. You can get the I'm getting what we might call the fronts of the string, all the possible front parts of the string. Okay. Then compare that with the next one. The next one is going to try to print out the tail part of a string. Okay. This would be the front part of a string, from the 0th character up to the ith character, because the +1 tells substring to go to use the +1 character as the end of the substring, but that means it goes up to includes I and doesn't include I plus 1. Okay, so that gave me the beginning of a string. Now, if I say substring I, that starts at I and goes to the end of the string. So this is trying to print out the tails of the string, but it doesn't quite work right. Let's see what happens when you do that one. Oops. Oh, I've typed the comments thing wrong again. Okay, let's just see what it did. First, we print out the beginnings of the string. That's this part here up to there. There's the beginnings, all the possible beginnings. Okay, and then here's the first tail. Here's another tail. Okay, here's another tail. Notice I'm getting all, but oh, let's see. What's Let me see. I thought that was. Oh, okay. That printed out the tails. There's two. I guess there. Yeah, I thought that one had. I thought that one had a little mistake in it, but it doesn't. No, I printed them all out. Start. Yeah, the whole thing. Then all but the first, all but the first two, all but the first three, all but the first four. Okay. So up to the finally just the last one by itself. So that complements this one, which starts with just the first, then the first two, then the first three, up to all of them. Okay. Now let's look at a slightly different way of doing the same thing. Okay. This would take the substring starting at I, going to the end. Okay. Which essentially is the same thing. That's what this thing means here. Start there. This just means start there and go to the end. This means start there and then I explicitly say go to the end. Okay, so those are two ways of writing the same thing. They both say, it's just that this one's a shorter way of writing it. You don't have to say go out to the end. Okay, and so then this one will print out the same output. See, it printed the exact same output. Okay, so I'm really just kind of playing games with strings, seeing like I can do slightly different things with strings. You can walk the string. Yeah, here I walk the string from beginning to end and print every letter. Same thing here. Walk the string from beginning to end, print every letter. Here I walk the string and print it out up to where I am. From the beginning, I print it out from the start to where I am, okay? And then here I print it out from where I am to the end. As I'm walking the string, I print from where I am in the string up to the end. Okay, here's a slightly different kind of thing I can do. I'm going to switch to a while loop. This one, what this one's going to do is it's going to look for hyphens and replace them with underscores. So it wants to walk a string and say, if I find a hyphen, change it to an underscore. Okay, so here's one way to do that. While the string index of hyphen is greater than 0. Okay, now that's kind of a weird thing. What I'm asking is there a hyphen in the string? That's the question. Is there a hyphen character in the string? So I ask the string to give me the index of hyphen. Notice I don't ask it directly, is there a hyphen in the string? I ask it for the index of hyphen in the string. If there is a hyphen, I get an index that's going to be a number from 0 up to 18. If there isn't a hyphen, it'll be a number from 0 to 18. But if there isn't a hyphen, remember, index of, when it can't find what you're looking for, gives you back -1. So if the answer is positive, I found a hyphen. Okay. If the answer is negative, there was no hyphen. Okay. So while there is a hyphen, is there a hyphen in the string? Okay. Then what I want to do is then call index of again to find the hyphen in the string. Okay. So I'm going to call index of, and so now that I know there is a hyphen in the string, I'm going to call index of, say, where is it? It tells me where it is. And then here I'm going to build up a string that replaces the hyphen with an underscore. So no, I'm using the part like we did. This is the beginning of the string. See, it's like what we did here, real similar to here, except that I don't want to include the hyphen. The I+1 character would be the hyphen itself. So I go substring 0 to I. I is where the hyphen is. So I go up to not including where the hyphen is. Okay. So that gives me the beginning part of the string, just like we did over here. Then put a hyphen. Now go, well, this gives me the tail part of the string, just like that we did here, but I want to skip over the hyphen again. So I is where the hyphen is, so I tack on. See, I'm adding 3 pieces together. The part of the string up to not including the hyphen, the part of the string that comes after the hyphen, and in between them, I'm putting an underscore. Okay. All right. So now this is kind of an interesting thing. How many times will this while loop loop? Now, remember, this for loop looped as many times as there are characters in the string. So this looped 18 times. This looped 18 times. This looped 18 times. How many times does this loop? How many times does this one go around? What's the answer to that question? Is it, I mean, the string is length 18. Does this thing go around 18 loops?
Would it just go around once?
Well, it will go around at least once because it has to check if there's an hyphen. Okay. Now in our string, how many hyphens are there?
2. 2.
2. So it'll go around twice because it'll find first this hyphen and then that one. So it's actually going to go around 2 times. See, it says while this thing is true, while this thing is true, there's a bunch of noise on the software. Yeah, okay. Right. Yeah. Okay, so it says while this thing is true. Now, at the beginning, this thing's got 2 hyphens in it. after one loop through, one of the hyphens is gone and it's replaced by an underscore. So the string will have one of the hyphens removed. Then there'll still be a hyphen. So loop one more time. The second time through, it'll get rid of the second hyphen. The third time it goes to up here, it'll actually go to this statement 3 times. It'll loop twice, but it's going to go to this statement 3 times. The third time, there won't be a hyphen, and this thing will be false. Okay, let's watch it. Whoops. I forgot. Oh, I keep forgetting these things. Okay. Oh, actually, let me go back and comment out all the code we're not interested in. We're not interested in this part right now. So let me block that out. Okay, so now our program starts here. We can just go to the part we're interested in. Okay, so, okay, here's my string. It's got 2 hyphens in it. I print out a blank line. Okay, now, while s1.index of hyphen is greater than 0. Well, there's a hyphen right there. So the answer will be that there's a hyphen at index 0, 1, 2, 3, 4, 5. Okay, so this is going to be true. Okay, well, there was now I ask, where is that hyphen? I find out it's at 5. Okay, now I build this string up here. Okay, I build that string up there. Then what you don't see it actually happen. Okay, but what's going to happen is, see, 1 hyphen turned into an underscore. Okay, what happened was it actually did 3 sub-steps in that line. It created this, which was the part up from HELLO. Then it added on the underscore. Then it built that string there. Now, let's try a game. There's really 3 steps here. I don't know if the Java visualizer will show us that it did this, then this, then this. I don't think it'll do that. I think it's just going to treat this all as one big line. Java doesn't care if we write it this way. But what we really know is that what happens is when it gets to this line here, it first does that, then it adds on that, then it adds on that. Okay, but I don't think it'll show it in 3 pieces like that. Okay, so print out the blank line, check for the index. Okay, there really is a hyphen. So find out where it is. The hyphen's at 5. Okay, let's see what happens when I click forward here. I think it's just going to do I think it's just going to do 37, 38, and 39 all at once. Well, let's see. It did 37, skipped 38, then went to 39. It hasn't done anything yet up here. Then it did 39. Okay, so it kind of did it all at once. It didn't show it. It didn't show it building this, then this, then this. So you have to that part you have to visualize in your head that this thing is going to do 3 things. I want to build up this string that has the underscore instead of the hyphen, and I do it by getting the part to the left of the hyphen, getting the part to the right of the hyphen, and replacing the hyphen itself with the underscore. Okay. Now let's see. So that didn't. There really are 3 steps there, but the Java visualizer isn't going to show them to us. So we can just go ahead and leave it as 1 line.
Okay. So does while and if do the same thing?
No. They both loop, but in very different ways. Okay. The basic thing about for loop is that you can pretty much say it's going to, you roughly think it's going to do that many times. It's going to loop from I equals 0 up to the last I. You're going to loop from the first I to the last I. Now, that's not 100% accurate because you could be incrementing I by 2s, you can increment I by 3s, but most people increment I by 1. So you could say I start from this I up to that I by 1s. So you can say
no, I said the while and the if.
Oh no, because while repeats, if just asks one single question. if only asks one question. Now let's see.
So you couldn't have like an if that like would keep on repeating, like
No,
if it,
no, no. Now let's see.
okay.
In class, go back and we have these examples. Oh, that file won't show up. There's something wrong with that file. Let me download it. No, this is kind of a quirky thing. I put a file up on the web server and the web server refuses to let me download it. The file is there, and it's kind of strange that the web server refuses to let it be downloaded. But it's let me get it off of my hard drive. I think it's there. Okay. Compare that and that. See, that's the question you have. How does this differ from this?
Yeah.
So in words, like, what do you tell somebody this does, and what do you tell somebody this does?
So it's like if the Boolean is true, then do that.
Yeah. And then what? Then when you're done with that, do what?
Oh, okay. So then you go on to the next line.
Yeah, you go on to the next one. Now, what does this one do?
So that's like while the expression is true, keep on doing that.
Yeah, it's like if over and over again. You can think of this as if over and over again. You check if that's true. If it's true, you do this. But
Okay.
after you've done it, you go back and do the if again. If this is true, do this again. Then go back and check if this is true. So in a sense, they're written real similarly, but this one's a one-shot thing. It just checks if this is true. If it's true, you do this. If it's false, you skip over, but you only check it one time. This one, you
Okay.
checking it possibly forever. If this thing never changes, you keep doing it forever. Okay.
Right.
So it's a good question because they look a lot alike. They
Right.
both ask the question, is Boolean expression true? Yeah, they're both asking, is Boolean expression true? Is Boolean expression true? The difference is this asks it only one time. This keeps asking it. This asks that same question over and over and over again. This asks that question just one single time. So if this is true, do this once, but this one will just keep asking and asking and asking. Okay? All right. So back over here, we ask that question once, at least. We always ask that question at least once. Okay. If there's a hyphen in the string, we replace it. Then we go back and ask again, is there a hyphen in the string? If there is, we replace it. Then we go back and ask again. Now in our case, there's 3 hyphens in the string. There's 2 hyphens in the string. So we're going to ask this question 3 times, but do what's inside here only 2 times. Okay, so go over here and ask that question once, replace 1 hyphen, ask that question a second time, replace the second hyphen. Now ask that question a third time, but now that question is Well, the answer is that the index of hyphen is -1 because there's no hyphen left in there. So now you finish. Okay. And if I want, I can put more hyphens in there. Okay. And now it'll loop as many times as it needs to. Okay. So now get rid of the first hyphen, get rid of the second, replace the second hyphen, replace the third one, replace the fourth one. Now it's going to loop just as many times as it needs to replace the hyphen. Okay. Now let's rewrite this using a for loop. I can do this one with a for loop too. Let's think about how I would do it with a for loop. Now, with a for loop, I'm going to walk the whole string. For, so I'm not going to do this. For int I equals 0, I less than s1 dot length, I plus plus. Now, think about now the logic's a little bit different. I'm going to walk the string from beginning to end. Let's see. Oh. I'm going to walk the string from beginning to end. What should I do in here? See, now I'm walking the string. So I'm going from here to here to here to here. What would I do inside here now? What is it I want to do? I want to walk the string. And if I land on a hyphen, I want to change it. If I'm walking the string, if I land on a hyphen, I want to change it. And if I don't have a hyphen, I don't want to change it. Okay. So what can I do here? What's an idea I could do here? Take, like, what's the first thing I can do? I'm at H. But I don't know I'm at H. I mean, the code here just knows that it's at the beginning of the string. What does it want to do at the first thing? What does it want to do at that place in the string?
Here to see if it's a hyphen.
Yeah, we need to ask, is it a hyphen? So get rid of this line of code and say, I want an if statement. If statements ask a question. Okay, how can I ask if a letter is a hyphen? First of all, how do I get the letter itself?
Use the character.
What do you mean? Use the character. What do you mean? Be real
Like
specific.
the car.
Be real
Like
specific.
like do s1.car at
Yeah,
zero,
char
at I.
Okay, I can say s1 dot char at. That method gets me the char at I. Okay, all right. So now I got that character. All right. So okay, so that's one way of getting the character. Now, what do I want to ask about it?
It's a hyphen.
Is it a hyphen? How do I ask? Is it? Here's a hyphen. How do I ask? Is it a hyphen?
Equals.
Would you put the double equal sign?
Double equal sign. Double equals. Equal sign is assignment, so it'd be double equals. Now the question is, would it be double equals or is it dot equals? Okay, and that's one of the differences between using the char at, which gives you a char, and using the substring, which gives you a string. If you use this one, you use dot equals. If you use this one, you use equals equals. So, because char is not an object, a char is a primitive. Okay, so let's try, we'll try it again later, we'll use the substring one. Okay, oh, that's not SI, it's S1. Okay. Ask the string what its character at position I, ask the string to get the character at position I, and we compare it to hyphen. Okay, what if it's a hyphen? What do we do if it's a hyphen?
You change it to an underscore.
Yeah, and we've already, and that code is already, that doesn't change. No, so it's just, it's that line of code right there. That line of code says, give me the string up to the I, that's everything before the hyphen, replace the hyphen with an underscore, and give me everything that's after the hyphen, okay? So there's the code that did the change, okay? Now, if you found a letter that's a hyphen, build a new string. Actually, we're replacing S1 with a new string that replaces the hyphen with an underscore, okay? Right, so let's see if this works. Now this should work, because, and now if we weren't at a if this was false, if we're not at an underscore, we just skip it and just go to the next character. If we do find a hyphen, notice that we're building a new string that replaces the old string with a string that has the underscore, the hyphen replaced by an underscore. Okay, so let's check if this works. Okay. Okay, now we're gonna, oh, okay, this is the one that loops, let's see. Let's get rid of some of the hyphens so we don't have to keep iterating so much. Okay, there's 3 hyphens, okay? Okay, here's the while loop version. It's gonna loop 4 times because there's 3 hyphens. 1 hyphen, the second hyphen, and the third hyphen. Oh, actually, we can't do that. No, actually, we can't test this thing now. Why? We can't test this one anymore. What's wrong?
No more hyphens.
No more hyphens. So we have to go back and so let's comment out this one because it already gets rid of all the hyphens. So let's comment that out so we can just go straight to the one that we want to test. Okay. Now the while loop one we just saw looped three times because there's 3 hyphens. The one we're going to do now is going to loop how many times? How many times is this one going to loop? Is 3 times the right answer now?
Like 16 or something?
Yeah, it was, I think it's 18 now. I think
18.
Because it's what? It's going to loop, it's going to do what? It's going to loop for what?
For every character.
For every character. Yeah, it's not going to loop for every hyphen anymore. See, that was what kind of nice about this one. This one looped for every hyphen. This one's going to loop for every character. So let's start. I equals 0. Okay, is the char at 0 a hyphen? No. So back in loop now, I is 1. See, now remember we initialize that and we go back. Okay, we're at line 42 and we're about to initialize I. Okay, we initialized I. We're at line 42 and about to check I. We check I. Okay, it's less than length. So now we're at line 44. Now we check the char at I. The char at 0 is capital H. Capital H is not a hyphen. So we go back up to line 42 because we skip over the if statement and go back to 42. Where are we in 42 right now? Real important question.
We're at the increment, right?
Yes, we're at the increment. So I'm going to click forward. I'm going to stay at line 42, but I is going to go from 0 to 1. Okay. I went from 0 to 1. We're still at 42. Where are we now?
The test.
The test part. Yeah, we're in the test part of 42. Okay. 1 is less than the length, so that's true. So I'm going to go to line 44. Okay. Char at 1 is a lowercase e. Okay, that's going to be false. So I'm back up to 42. Okay, I'm at the increment part. Increment I to 2. I'm at the test part, test, down here. Okay. I'm at character 2, which is an L. Okay. Now increment to 3, test 3. Now I'm checking character at 3, which is another L. Okay. Go back up here, increment to 4. Check at the check that 4 is less than the length. Now I'm checking character at 4. The character at 4 is a O. That's the O. Okay. Go to 5. Now at 5 is when we get to the first hyphen. So let's see what happens. Okay. So now I'm checking S1 char at 5. That's actually the first hyphen. I'm down here. Okay. Now I build that new string. Okay. The hyphen got changed. And now I'm ready to keep walking the string. Now I'm going to go to character 6, which is the letter T. Okay, so the letter T, skip over it. Now the letter O, skip over it. Okay, now I'm at 8. 8 will be this next hyphen. Okay, so I'm checking the char at 8. That's another hyphen. Okay, and notice that I'm looping now for every character in the string. Okay, now, which is better? You know, if you think, that's actually it's not a great question. The answer is neither one is better. This one did what we wanted with a while loop. This one does what we wanted with a for loop. This one loops 3 times. This one loops 18 times. So you might think, well, this one's faster. And the answer, no, it's not faster. Does anybody think of it? Why is this one? Why would you think, somebody says, but this thing loops 3 times, this thing loops 18 times, so this one's way faster. Can anybody see what's wrong with saying this one's way faster? It's a subtle answer.
Because for the bottom one, it only actually does anything for like 3 of those loops.
Yeah, okay, it only actually does anything for 3 of those loops, but it still has to loop 18 times. And this thing only loops 3 times. So you might say, well, this one does 3 things and this one does 3 things, but your friend's going to say, yeah, but this thing loops 18 times. That's a lot of loops that are still, you have to, we did have to step through all of them. Okay, so why is this one not faster? Why is this one not faster than this one? There's something else going on. Is this one really doing less work than this one? This one still had to step through the string. It had to go H, E, L, L, O, underscore, hyphen, T, O, hyphen, A, V, R, Y. It had to step through that whole string. Why is this one not magically somehow doing less work? The hint is what I underlined. The while loop's doing every bit the same amount of work as the for loop. What do I mean by that? The for loop had to check, it had to look at the H, it had to look at the E, it had to look at the L, it had to look at the L. Notice it had to do this char at for every one of those. So it looks like this is doing 18 units of work, because it's looking at the H, looking at the E, looking at the L, looking at the L. This one seems to just say, oh, I found one underscore, I found another underscore, and I found another underscore. But what's really happening over here? Why is the while loop working just as hard as the for loop?
It has to check that there's a hyphen in every.
How would it find the hyphen?
It has to go through each character.
Yes, exactly. Yeah, it's got to look at every. So the extra work is buried in index of. The while loop does all the work the for loop does. It's just that the work is buried in index of. Index of has to look at the H, look at the E, look at the L, look at the L, look at the O, finally finds a hyphen. In fact, this one does more work than this one. Okay, now be real subtle. Can you tell me why this one's actually doing more work than this one, and this one is actually slightly faster than this one? This is starting to think like real programmers. This is how real programmers will think. This guy turns out to actually be the better solution. What is this guy? Why is this guy doing more work? The answer is still right over here. Think now, the thing to do is programmers learn to think about every single little tiny detail because they all matter. Here's what I want to think about. Suppose this string was a Google string and it was 1 billion characters long, which is not unusual at all. You know, Google works on things of size in the billions all the time. This is really, think really that this is a string with 1 billion characters in it, okay? And you're trying to find the hyphens in there, okay? What's wrong with this guy? And why is this one way faster, actually? How do you find the underscore? How do you find it? We said it a minute ago. How do you find it?
There are a bunch of people answering you in the comments. or
Oh,
group
okay.
chat.
Yeah, let's see. Yes, does it have to? Okay, so tell me. Somebody say it in words. What is index of doing? Index is every time I call index of, it does what? It starts with H and goes through until it finds a hyphen, right? Then I replace the hyphen with an underscore. Then I loop and then I say, find me another hyphen. But what does this guy do? Starts with the H, keeps walking until he finds a hyphen, finds that hyphen, and I replace it. Then I want to find another hyphen. This guy always starts back at the beginning because it doesn't know where the hyphens are. When you call index of, it's supposed to find the first hyphen. So it always starts back at the beginning. If this is a billion character string, this is going to walk the billion character string 1 billion times. Okay. Well, as many times as there are hyphens. For every time you ask for a hyphen, it has to walk the whole string. So if you had a string that was 1 billion characters with 100 hyphens in it, this would walk the billion characters. Let's see, I lost mine. This one would walk the billion character string, say 100 times, once for each hyphen. How many times does this walk the string? How many times does the letter H get looked at?
Just once.
Yeah, and the letter E gets looked at once. See, this thing, if the string is 1 billion characters long, it loops 1 billion times. This one, if the string is 1 billion characters long and there's 3 hyphens in it, it loops, it actually is walking the string 3 billion times. Yeah, depending on where the hyphens are. If the hyphens are at the end of the string, it has to walk through the whole string to find the hyphens. So this one's actually doing more work than this one because the index of has to walk the string itself. Here, we just walk the string one time from beginning to end. Here, every time we call this, we have to walk the string from the beginning to wherever, well, we walk the string from the beginning until we can find the first hyphen. Okay. Surprisingly, this one turns out to actually be a little bit slower than this one. because it was having to keep doing this index of thing over and over. So even though it looks like it was faster because it only did 3 loops, there's a buried loop in there. In there is something that's actually a hidden loop from you, a loop that would say, look at the H, look at the E, look at the L, look at the L, look at the O, look at the hyphen. Oh, I found a hyphen. Then when you call it again, look at the H, look at the E, look at the L, look at the O. Then this will be an underscore. Then I'll look at the underscore, look at the T, look at the O, find another hyphen. Okay. Right. So it's subtle. It turns out this one is actually slightly better because it walks the string from beginning to end one time. This one will end up walking the string more times than you realize because of this buried index of. Okay. Now, eventually, you're going to spend a lot of time learning to think this way. There's a whole course on what we call data structures and algorithms that spends a lot of time talking about analyzing code in real detail and asking questions like, how many steps does this do versus how many steps does this do? This one essentially does 1 step for every character in the string. So this one really did 18 steps from beginning to end of the string. This one did way more than 18 steps because it had to keep looking at the H. It had to keep going to the beginning of the string and looking for a hyphen. Then go back to the beginning of the string and look for another hyphen. Then go back to the beginning of the string and look for another hyphen. So it actually did a lot more. Didn't do just 3 steps, 1 for each hyphen. Okay. So there's a lot of interesting things going on here. Writing code this way can sometimes be better. Sometimes writing code this way is better. Okay. All right. Now, let's look at another example of playing around with a for loop, or playing around with these loops. Here's a cute example. Take a string and reverse it. Take a string and create a new string that's this one in reverse. Okay. So this is something that gets done pretty often. It's not unusual at all to need to reverse things. So what I'm going to do is I'm going to create an empty string to hold the answer. That's going to hold the reversed string. Okay. Then I'm going to do a loop that just walks the string from beginning to end. Okay. And then what I want to do is S2, I want to build S2. So I write a funny line here. I'm going to take S2 and I'm going to turn it into, notice I got S2 with something added to the left of it. Okay. So the new S2 is the old S2 with something tacked on to the left. Now S2 started out empty. Now what do I tack on to the left? The ith character. Okay. Now let's just do that. Let's just do that up here. Let's pretend that we're going to do what this code does. I'm going to take this letter and move it down here. Then I'm going to take this letter and put it where? Where does it go down here? If I want to build this one in reverse, where does that E go when it moves to string 2?
Goes before the H, right?
Yeah, it should go before the H. Now, where does the L go?
Before the E,
Yeah. Then where does the next L go?
before the L.
Yeah. So see, notice that's what I'm doing. Now that's what I'm doing down here. As I get to the ith character, I put the ith character. So remember this trick here, substring I to I plus 1 gives me the ith character. I'm using substring instead of char at. So that's the ith character. I put it on the left of what I have so far. S2 is this thing I have so far. So when I get to the O, I put the O on the left of what I have so far. Then I get to the space and I put it on the left of what I have so far. Okay, so I start with an empty string and I walk this string from left to right, and I take each character here and move it down to here on the left. Okay, and if I visualize this, We can watch it happen now. Okay, so there's the string hello there. Create the empty string. Now walk the string, start at the beginning. Okay, now here, I'm going to take the empty string, and put on its left the first character from our string. So that's the H. So H ended up there. Now loop. Okay, now I'm up here at the increment. I did the increment. I is 1. Now I check if the increment is less than length. Okay, now I'm back here. I is 1. So that's the E. So I'm going to take the E and put it on the left of what's now in S2. So when I take, and I'm going to make S2, the new S2 is going to be the old S2 with the E on its left. So I get the E out of hello and put it on there. Okay. So now I got EH. Then I loop up, increment I to 2. Okay. Now check to 2 is less than the length. And now I'm going to take letter 2. Letter 2 is the first L. That's letter 2. And that L gets put on the front of the string we're building up. And then you can just keep looping through and you build up the reverse string from right to left. Okay, so that's how you can reverse a string. You know, this little trick of putting the new stuff on the left of what's there already. Okay, so notice I'm walking a string from beginning to end, and I'm building a new string as I walk the old string. Okay, let's look at one more example that's similar to this. Here's a more complicated example. Java has a 2 lowercase and a 2 uppercase method. What about a 2 opposite case method? Something that takes the uppercase letters and make them lowercase and take the lowercase letters and make them uppercase. There isn't one, so we're going to write our own. So we're going to write our own 2 opposite case methods. So here's the 2 opposite case method. It takes in an in string and it wants to give back a new string, which is the 2 opposite case version of the string we started with. Okay, so we're going to do it similar. We're going to start with an empty string and build up the answer. Okay, so it's very similar to what we did, except instead of building it in reverse, we're going to build it in the right order. But every time we put something on the new string, we should put the opposite. Like when we build up the new string, capital H should become lowercase h. Lowercase e should become uppercase e. Okay, now watch how we do this. It's a little bit tricky. So I'm walking the in string. I get the char at. Now here I'm using char at instead of the substring. I get the char at I, and I want to know, is it a lowercase letter? Notice I compare it to the number 97 and the number 122. And I say that if the char at I is more than 97 and less than 122, that means it must be lowercase. So I'm going to convert it to uppercase. Well, where did I get those numbers from? Google something called ASCII. The ASCII system is a system that gives numbers to every letter. Okay, so it's a system that's in the universe. It's universally used to give a number to every letter. Okay, and let's see. This is a pretty bad ASCII table. Okay, here. Lowercase a is number 97. That's the number that the international organizations have given to the lowercase a. Then the lowercase z is number 122. So if the number of a letter is between 97 and 122, if it's between 97 and 122, it's a lowercase letter using the ASCII table, okay? And then I could also look in the ASCII table for the uppercase letters. The uppercase letters are between 65 and 90, okay? So I can use, that's why I use char at, because char at gives me characters which I'm allowed to compare with numbers. If I used the substring here, I wouldn't be able to do this trick. I couldn't compare strings to numbers. So here it was useful to use char at because Java lets you compare a character to its ASCII number. Okay, so that's how I can tell I'm a lowercase letter. Then I splice it onto the end of my out string. I'm building up my out string is my out string so far with that letter uppercase. So the lowercase letters get uppercase, and the uppercase letters get lowercase. Anything else just gets added on without being changed. Because what if a letter is neither uppercase nor lowercase, like numbers? So here's a good example of using if-else statements. If I'm lowercase, convert to uppercase. If I'm uppercase, convert to lowercase. Otherwise, things that are neither upper nor lowercase, they just get put on the end unchanged. And then I return the string I built up. Okay. And we run out of time, so I'll just show you. If you run this, you can see how it took hello and turned it, it did the two opposite cases there. So we don't have time to step through the code, but notice that I'm combining a method with a for loop and if statements. Now, this example here uses everything we've learned so far: string methods, for loop, if statements, a method that takes in a parameter, returns something. Okay, that example there now includes pretty much every idea we've learned about is in this one example. And it's not very many lines of code, but there's a lot of ideas there. Okay, so we run out of time. I'll put these examples up on the website, and then next week we'll do nested for loops. That's what we're going to be doing next week, is nested for loops. Okay, and because it'll take us 2 days to do examples of nested for loops. Okay, so look at these examples. Our examples are going to start becoming more and more complicated. We're starting to combine a lot of ideas now. So we're going to do more and more things like this, where everything we learned is going to be used in one piece of code. Okay, so if you have questions, please write, and I'll go ahead and end the meeting at this point. So have another nice weekend, and see you on Monday. Bye.